Hello there, good afternoon. Welcome to today's Speakers for Schools broadcast. We are delighted that you've been able to join us today. This session is going to last around 45 minutes and it will include an interview and presentation with one of our speakers before later moving on to a student Q&A. Questions for our speaker can be submitted via the Q&A function underneath the stream on your screen. You may have to scroll down a little bit to see this, but it will be open throughout the broadcast. So we encourage you to submit questions in response to anything said today, as we'd love to hear from you. If you are experiencing any issues, please let us know via the Q&A box and we will do our best to support you throughout the broadcast. We are very excited today to welcome Professor Chris Budd OBE, as well as being the Professor of Maths at the Royal Institution and Gresham Professor of Geometry. He is passionate about using maths to solve real-world problems, from weather forecasting and climate change to food distribution, telecommunications, and even saving the whales. With a strong commitment to making maths engaging and accessible, Chris has played a key role in public science education, including founding the award-winning Bath Taps into Science Festival. His work has had a real impact and his mathematical models are used in the Met Office weather predictions. Thank you for joining us today, Chris. I will now hand over to you to see a couple of slides from yourself. And once you're done with those, we can move on to some questions. Thank you so much for joining us today. Hi.
Hi, Nick. Well, really very nice to be with you and with everyone out there. I hope the weather with you is as nice as it is at Bath. It's a lovely, lovely sunny day here in Bath today. And I will talk a little bit about the weather in this talk. So I want to talk to you about the possibilities that maths opens up to you. So I know many of you, when you go to school and study maths, you might think, well, you know, what's the point of doing this? And what I want to do in this talk is show you that you are really opening the whole world to you by doing mathematics. So I'm going to tell you a bit about career opportunities in maths and stats, but also talk about other ways in which maths can benefit you and your lives. So we'll start, though, with some perceptions of maths. So here are some common views on maths, shared, I think, by very many people. One is that maths is hard. It's true, maths is hard, but so many other things that are worthwhile doing. Another is that maths is boring. Well, some bits of maths are boring, but lots and lots of maths is really, really exciting. And that's one of the reasons I do it. Maths has nothing to do with real life. People often think that. And that, I'm going to show you in this talk, couldn't be further from the truth. And then everyone thinks that mathematicians are mad. Well, you can decide from that whether you think that's right, having listened to me and my talk. But the point is, really, none of this is true. It's certainly not true that maths has nothing to do with real life. And what I want to show today is that maths and stats are absolutely vital to society. They lead you into many, many different universities degrees and to a huge number of careers. And one of my favorite statistics is that one of the largest employers of mathematicians in the world is Hollywood. And you might think, what's Hollywood got to do with mathematics? Well, I'll let you think about that for a minute, and I'll then show you later on how you can become a film star by using mathematics. But I thought I'd start with a little story. And this is a sort of true story in that I've worked in my career sometimes with the police. And the police have a forensic service. In fact, you can watch TV programs about forensic scientists working for the police. And they very rarely tell you that a lot of the work of the forensic service uses mathematics. So here's a little story. So I want you to imagine that a burglar, there is the burglar, has robbed a bank. And they've gone into the bank and they've got a satchel full of cash. And they run out of the bank and they're met by their getaway car. And they jump in the getaway car and they storm away, and the police follow them. So that's the scenario. You know, you can often see that happening on TV shows about police and crime and so on. So the car goes through past a CCTV camera, and the CCTV camera takes a photo, which is great. They've got a photo, but the problem is that although they got a photo of the number plate of the car's going really fast, probably going something like 60 miles an hour down a 20-mile-an-hour road, and the camera's not quite fast enough, and as a result, the photo is blurred. So here we have a picture of the original car number plate. Incidentally, this is carefully chosen, so it's an anonymous car. I don't know of any car which has this number plate. And underneath, you can see the picture that the police have found, which is blurred. So that's all they've got, is that picture of the car number plate. So the question is, what can they do? Can they work out what the car number plate was from that blurred picture? Now, on its own, that doesn't seem at all easy to do. But there's actually a very nice solution to this. And the solution is you take the picture of the car number plate to a mathematician. So that's what you do. You take the photograph to a mathematician and ask if they can work out what the original number plate was. Now, why should you take a photo to a mathematician? Well, when you take a photo on your mobile phone, that photo is converted by the mobile phone into lots and lots and lots and lots of numbers. So a typical photo, when you take it, you might see something like 3 MB after the photo. That means 3 megabytes. And that basically means 3 million numbers are used to represent that photo. So anything to do with numbers immediately involves mathematics. And what mathematicians can do is that they can work out the process of how those numbers get changed when a photo gets blurred. And they can formulate that using mathematics. And I'm not going to do too much maths in this talk. It's mostly going to be about careers, but just to brace you for this and the next slide, basically what they say is that the numbers, we'll represent them by a thing called a function f. The blurred photograph we'll call h, and the process of blurring we'll call g. Right, brace yourself for the next slide, everyone. Here we go. This is the only big maths in the talk. There we are. That is the formula that mathematicians come up with to take the original photograph f and turn it into the blurred photograph h. Now, it doesn't matter at all if you don't understand that formula. That's not your job. That's the job of the mathematicians. If you're doing A-level, you might recognize some of the bits of that formula, such as the integral sign. And it also involves this wonderful mathematical quantity, infinity. Anyway, it doesn't matter what the formula is. The point is there is a formula. And once you have a formula which takes you from a photo to a blurred photo, with a lot of really clever mathematics, you can go the other way. You can what's called invert that formula and take the blurred photo back to the original. So you can work out a formula for doing that, and then you can code that up into a computer. And then you take your blurred photo and you put it into the computer. It applies the formula to it, and the output is that. So that's what happened when we took the photograph that was the original blurred photograph of the car number plate and put it into our formula. And there we have something like that. And you can quite clearly see the original number plate. And because the formula is mathematics and therefore true, the courts are quite happy to accept that as evidence. And this is used as evidence in courts of law. So mathematics can be used to de-blur photographs. It has similar applications. If you have a medical image and it's a bit blurred, you can make that sharp again. Or if you take a picture of a star by a telescope and it's blurred, you can make that sharp again. It's the same mathematics that works every time, and maths is really important in the careers service, in the forensic service. So that's just giving you, I think, a taster of how maths can be used. But maths isn't just used in forensic service, it's used absolutely everywhere. It's entirely true to say that maths has made the modern world possible. Now, you're watching me because you are using the internet. And the internet was invented basically by doing a whole load of mathematics. Tim Berners-Lee, when he invented the internet, was using a lot of mathematics. Mobile phones are huge amounts of maths in a mobile phone. GPS wouldn't work without maths. Music is stored again as numbers using maths. Your sat nav works using maths. Your CDs, if you still use CDs, work using maths. Radar uses maths. TV uses maths. All of our modern technology could not work at all without maths. And that's really saying something, because we basically live in a society where mathematicians are making all the progress in terms of technology. And here's some, interesting mathematical facts. 70% of all jobs require some level of mathematics. By some level, I mean a reasonable level at GCSE. So, that's 70%. That's, pretty well any job you're going to apply for is going to need some sort of maths. Here's another one. Maths graduates earn more than almost any other profession on average. There's only two professions I know which earn more than maths on average. One is medicine and the other is law. But maths is, I think, the third highest earning profession. If you go to university into almost any degree, maths is useful. My daughter did psychology at university. She emailed me at one point. Dad, she said, I'm doing maths. And the reason she was doing maths is that she was doing a whole load of statistics. And even if you don't do a degree in maths, maths is still very, very useful in all sorts of other aspects in your life. Most people at some point have a mortgage, and to work out your mortgage payments, you need maths. To work at interest, if you buy something and you pay interest, APR needs maths. You need maths to do your family budget. You even need maths to do all the calculations involved with catching a plane, working out whether you're allowing enough time to change planes and stuff like that. So maths really, really is incredibly useful. But the main thing we're talking about today is maths in careers, and in a huge number of careers involve maths. I mean, it used to be said that the only career that used maths was teaching. And whilst teaching is a fantastic career and your teachers are amazing people, that's not the only thing you can use maths for. So about I think some statistics, something like £200 billion of the UK economy is due to the use of maths. And one of the reasons for that is that the finance and banking industry employ lots of mathematicians. The computing industry, IT, employs lots of mathematicians. If you work in insurance, that employs mathematicians. I do a lot of work in weather forecasting and environmental science, and that uses lots of maths, and I'll show you why in a minute. If you want to be a spy, GCHQ, a huge employer of mathematicians to break all the codes. My sister's a doctor. She says I save lives as a doctor, and that's absolutely right. But hospitals make a lot of use of medical scanners, things like MRI machines, CT machines, and medical scanners are all designed using mathematics. Transport, to design transport system uses maths. Governments, social services, I've used maths a lot in food to make sure that food products are right. And the thing which I said right at the beginning of my talk was that maths is used in the film industry. And here's a picture of Shrek. And Shrek, I hope I don't upset anyone when I tell you that Shrek actually isn't real. Shrek is an animation, and the animation is a surface which is created using mathematics. And to make that surface look realistic and move around so that Shrek becomes a real character, and to make him lit so he looks right, all of that uses lots and lots of mathematics. And Pixar, the company that does all these great animations, was actually founded by mathematicians. So if you want to be a film star, become a mathematician. go and work for Pixar, and you'll find it's got lots of careers. Now, one of the things about maths, keep talking about maths, but and it's very easy to think that maths is something that just happens in books, but maths is created by mathematicians, and mathematicians means people like you. One of my favorite mathematicians is on the next slide. This lady, Florence Nightingale. Everyone knows of Florence Nightingale, one of the most famous people that ever lived, and everyone thinks that she was a nurse. She wasn't. She was a mathematician, and she created the field of medical statistics, and she saved lives by carefully recording data on people and using that data to help inform her medical work. So she was primarily a statistician, and much of modern medicine relies on the statistical ideas that she came up with. So she was a real person doing real mathematics, and really, really famous. Here's some other mathematicians who you may not have heard of, but you certainly heard of what they do. So bottom left, we have Ada Lovelace. And Ada Lovelace was one of the people that invented the computer back in the 1800s. To her right is a guy called Radon. He invented medical imaging. That's what we just talked about. Above her is Euler, who invented much of the maths that we use in the internet. To his right is Galois. He invented much of the maths that we use in modern CDs and in communication. And above them are two incredibly wealthy mathematicians. This is Mr. Brin and Mr. Page, and these are the inventors of Google. And they invented Google by applying the maths that they were learning at Stanford University to a real world problem of how you search the internet. And they did all the calculations, designed Google, and the rest is history. And now Google, I think, is one of the wealthiest companies in the world, probably more wealthy than most countries. And they've had an enormous impact all through. If you're doing A-level and you're doing matrices and you think, what's the point of this? Google was all based on matrices and things called eigenvectors, which Brin and Page used to design Google. So these are kind of people. They're all kind of mostly, well, some of them are dead and some of them you don't know, but there is one mathematician that you have heard of who did some maths which might be of use, and that was me. So I'll just tell you a bit about some of the stuff that I've done. During COVID, I worked with an organization called SPI-M, which is a scientific panel for infectious disease modeling. And we were doing lots of calculations for the government to help them advise them on COVID. So here's a picture of the number of cases reported in COVID by date from when COVID started in 2020 until kind of when it fizzled out in the middle of 2022. And you can see various peaks and then decays, and then peaks and then decays as COVID was going on. And the job that we had was to advise government on fairly grim things like how many people would die in COVID. And we did this by constructing what are called mathematical models. These are equations where you can use those equations to predict what's going to happen next. And here was the results of some of the calculations that were made. There are three curves here. The yellow curve shows the number of people who are likely to get COVID. In other words, you start with everyone likely to get it, and then it drops as people get immune and so on. The red curve is the number of people that have got COVID and possibly died in the process, and the blue curve is the number of people that get infected. And so various mathematicians, myself included, did a lot of calculations on predicting things, and we came up with a very frightening prediction that about 500,000 people in the UK would die if nothing would happen. Unfortunately, the government took notice of these predictions, and that's why they brought in lockdown to give the system a chance to kind of sort itself out and bring in things like immunization and so on, and the vaccine to prevent that. So that was all in large part based on the predictions by mathematicians. So that's one thing I've been involved with. Another thing I do a lot of work on is climate prediction. And so, as was said in the introduction, some of my work is used to inform the Met Office computers when they do predictions. Here's a prediction of the climate between 1850, when the Met Office was founded, and 2020. And the black wiggly line is the observed temperature going steadily upwards as we go into global warming. The red curve is the prediction from our computers over that period, which is pretty close. And the blue curve is what we predict would have happened if no carbon dioxide was put into the atmosphere. And this curve allows us to convince government that it's carbon dioxide which is causing the problem, and that's why we need to control it. And then you can go forward into the future, and these are the predictions that we then make. These are various climate centres. The green one, the Hadley Centre, is the one at the Met Office, predicting a 3.5 degree temperature rise over the course of this century if we do nothing else. So this is where mathematics is used to predict what's going to go on and inform government. There are different predictions, and they all depend upon assumptions you make about how much carbon dioxide people will put into the atmosphere. But all in all, we're predicting quite a big rise, and that's where climate change results come from. It's all, again, mathematicians making predictions and then informing government. So I hope in this short talk I've given you some good idea that mathematics that you're learning at school really, really is useful and really can make a big difference to the world, and also that it can give you the opportunity of a really interesting career. So I'd like to say, there are limitless possibilities with what you can do with maths, unlimited career opportunities. And if you want to look at some of the opportunities for careers, there's a website called the Maths Careers website, www.mathscareers.org.uk. And if you go onto that, you'll find all sorts of information about careers and interviews with people. And then there are different sections for different area time, whether you're at the sixth form or year 7 or anywhere in between, of different opportunities for careers in mathematics. And at that, I will stop and hand it over to questions.
Thank you, Chris. That was really fantastic and really interesting. I thoroughly enjoyed that, and I know our lovely audience of school students definitely did too, and teachers. So thank you so much for those slides. Really interesting stuff. We're going to move on now, like you said, to a couple of interview questions, if that's okay with you. Our first one is so that the young people can get to know you a little bit further. Could you tell us about your career journey and your current role?
Yes, so I've had a not a straight career journey. I went to school in London. I come from London, and then I went to Cambridge and did my degree in Cambridge. But whilst I was at Cambridge, I every summer I went to work for a company called Marconi, and mostly designing radar systems. And that got me interested in the way maths is used in industry. And then after Cambridge, I went to Oxford and did what's called a PhD, which is a degree above an undergraduate degree. And then from doing that, I went to work for a company called the Electricity Generating Board, generating electricity. And I worked for them for a few years, but unfortunately, the company decided to restructure, and the restructuring meant that they closed down the laboratory I was working in. So I moved from that company to firstly the University of Bristol, and then I'm just celebrating now being 30 years at the University of Bath. And my work here is a whole mixture. So at universities you do teaching undergraduates, which is what most people think of universities do, but I do a lot of research, and most of my work, as you probably gathered from my talk, is working with different types of industry, essentially helping them solve problems using mathematics.
Wonderful, thank you. That was really informative. And you touched upon our second question, really, which is, what was it that first sparked your interest in mathematics, and how did you decide to pursue it as a career?
So it might sound a very strange story, but I'll tell you it because it's true. I can really pinpoint everything in my life to an incident that occurred in 1970. I have to confess, I'm very old. I was born in 1960. But in 1970, the Apollo 13 mission went up into space, and there was an explosion in Apollo 13, and the astronauts were stranded. And mission control in Houston had to do a huge amount of complicated mathematical calculations to work out how to bring them back. Now, I was very lucky to have a wonderful teacher at school who got us in the class all involved. It was primary school. I was in equivalent year 6, to try to do some of the calculations. How would we imagine getting them back? And this was all happening at the same time as the actual thing was happening. And we were trying to do it, and they got them back. It was amazing. The Apollo 13 was rescued by all these careful scientific things, and that was so exciting. And seeing how that worked, that I just felt at that point, that's what I want to do. I want to be someone that can do that. So Apollo 13 might have been a failure and it didn't get to the moon, but for me it was a huge success, and that it got me interested in maths and science. So there we go. Thank you, Apollo 13.
Fantastic. Great. Thank you so much for sharing that with us. So you've touched upon some kind of ways that maths is more than just kind of numbers and equations and the way that we use them in real life. So if you'd like to quickly just touch on the next question, which is, most students just think of maths as numbers and equations.
Yeah.
How would you describe real world impact of mathematics, and how it isn't just what we learn in school? You did touch upon some of these examples in your slides. So
well, I mean, as I say, it's almost limitless. So one of the biggest ways that maths impacts on our life is through data. So when you listen to the news and it says there's been let's say a 10% increase in let's say road traffic accidents, what does that mean, and how should we interpret it? And so understanding data, again with COVID, we were getting data coming in all the time, and trying to understand that and use that to predict was a huge area that maths was important. But data on its own, numbers, most people find pure numbers quite hard to understand. So another thing is, how do you present data? And that's then the kind of how you communicate using maths, and that's mostly pictures. So graphs. So when you're drawing graphs at school and trying to understand what a graph means, and one of the things we were trying to explain to politicians is the concept of exponential growth, which is, this is how diseases work. So if you have, say, one person infected now, you might have 2 in a week, and then 4, and then 8, and then 16, and how that rapidly grows. So understanding these concepts of growth and so on. So that's really important. Another thing that maths is really useful for is information. So all the information in a computer and on your phone, and possibly even in your head, it is stored using sort of numbers. And so the question is, how can we make sense of all that information? I think one lovely statistic is that the largest amount of information in the world are photographs of people's pets on WhatsApp or something like that, or in the internet. So how can we make use of all that information, and both for good and for bad? And another area, I say I work for the power industry. We all rely on electricity working. When we switch a switch, we got electricity. Well, why? Why have we got electricity? How's that electricity produced? How has it got to your house? How is it reliable, and how might we generate it in a way which doesn't involve carbon dioxide, and how might we run an electric car on something? All of these require mathematical formulae. So I say it's really hard for me to think of areas where maths isn't used. I mean, maths is even used in Google and ChatGPT and so on. They're all, artificial intelligence is mathematics.
Perfect. Yeah, that makes a lot of sense. Great. Thank you for that. So our next question. You've worked in many different areas, such as climate change, weather forecasting, as you mentioned, and even saving whales. What has been one of the most exciting or unexpected projects that you've worked on in your career?
Unexpected. So I had a lot of fun working with Shakespeare's Globe, which is a theatre, and they wanted to understand how to predict ticket sales for their theatre shows, and both before and after COVID. And they had lots and lots of data, and we analysed all that data. Say, maths is all about data, and were able to provide a formula for them, so that if they knew 6 months before a show how many tickets had been bought and what sort of person had bought them, sort of age and where they come from, they could then, using our formula, pretty accurately predict how many people come to their show. And that was rather fun. It was a bit different from what you'd expect, but it was fun because it saved them money, because it meant they didn't waste tickets. And also it's Shakespeare, and Shakespeare's always fun. So that's one area. I think a piece of work I've done recently, which I'm actually quite proud of, is working with, well, one thing often said, what's maths doing to help people starving around the world? And we were working with farmers in Africa, and able to help them understand the impact of climate change on their crops, and give them really quite helpful advice on what would happen in the future, and how they should diversify the way they're growing food. And by doing that, hopefully we are literally saving starving people in Africa.
Perfect. Thank you so much. Great. So another question. What are some sort of career opportunities available to students who study maths? What kind of industries could they work in?
Well, the answer is almost all industry, and it's going to get bigger and bigger. So the big growth industry at the moment, outstripping everything, is AI. And you've probably heard a lot about AI. It's in the news all the time. And the government has recently invested a lot of money into developing AI, and careers in AI. So this is, the big growth area, and companies are falling over themselves to employ AI specialists. So what's AI? Well, basically, it's mathematics. All AI is based on mathematical algorithms in a computer that make use of data. So all of the careers in AI are hugely dependent both on mathematics and on computer science, which basically is related very closely to mathematics. So that's a fantastic employment area, and that's only going to go through the roof. But I mean, there's also many other careers. I mean, as I said in my talk, the finance industry uses lots of maths. That's never going to change. And the telecommunication industry uses lots of maths. And the creative industries are increasingly using maths. As I say, Pixar, the film industry, the music industry, all of these use mathematics.
Yeah, perfect. Thanks so much, Chris. Great. We've got time for another couple of questions, so I'll fire through. What skills beyond mathematical ability are important for someone considering a career in applied mathematics?
Well, where do I start, really? The key skill with anything like this is the ability to just solve problems, to organize your thoughts, to gather evidence, to think what tasks need to be done, and then apply themselves to that. Now, that's not just true of maths, that's true of many, many other things, but mathematicians are particularly, let's say, trained to do that, because much of mathematics is about problem solving. So that's one skill. Then there's the skill of the raw mathematical skill, being able to solve the equations. But all of this would be completely wasted if you couldn't, at the end of the process, then communicate your results to people that are, let's say, not mathematically trained. So the ability to communicate to other people is also very important. And you specifically say applied maths, and most applied maths, the work I do, isn't done in an office on your own. It's done in a team. So the skills of working with other people and being able to talk to people from all sorts of different areas of life are important as well. But of course, those are life skills as much as math skills.
Absolutely. Yeah. Perfect. Thanks so much, Chris. So one more question then to close. Many students struggle with confidence in maths. What advice would you give to those who find it quite challenging?
Well, this may not be advice, but reassurance to say we all find it challenging. I think it's very normal for mathematicians to be stuck. You look at a problem, you can stare at it forever and get nowhere. So it's normal to be challenged, and nothing really to feel frightened about. So the skills to do maths are the same for any challenging subject: perseverance, not giving up, trying different approaches, realizing that it's not just you, that everyone else is the same, not feeling you're particularly stupid because you can't do it because everyone feels exactly the same. I don't think that maths is any different from any other subject in that regard. I mean, people talk about maths anxiety, and yes, people get anxious about maths, but I think people get anxious about many things. And I think the general cure for any anxiety is just to, first of all, try easier things which you can do, and gradually build up confidence, doing harder things, not giving up if it's a struggle, maybe putting it to one side, coming back later. And as I say, maths, the sort of maths I do it in teams. I work with lots of other people. We all support each other. We ask each other for help. Don't be afraid to ask for help. And anyone can be a mathematician. Anyone can be a mathematician. You don't have to be. I appreciate that I'm very stereotypical, white, old, wearing glasses type mathematician, but anyone can be a mathematician, and it's wonderful. I work with very, very diverse teams from all sorts of people, and often it's the younger people that make the greater contributions.
Lovely. Thank you so much. That leads us quite nicely on to if you have any final thoughts or feelings to share with our viewers today before we end the session.
Well, yeah. So my main thought is just this point I said that I've been doing in this game for 60 odd years, and I've seen maths just getting more and more exciting and interesting. When I started maths, computers had really only just got going. Calculators were pretty novel. The internet wasn't even thought of. And I've seen this huge explosion in my lifetime of the way that maths can be used and reach and brought into the kind of the general way that we do things in our lives. And that's only going to get faster and continue to go bigger and bigger. I mean, we're seeing this already with AI. Think what's happened the last 5 years with AI. Well, where are we going to be in the next 5 years? So the possibilities are absolutely incredible. And who's going to do this? Well, it's not going to be me. I've had my fun. It's going to be you, as in my audience I'm speaking to now. So all of you at school, these are the really, really exciting possibilities available to you. So don't think that it's all been done. There's nothing more to do. We're just at the beginning of a huge dawning of massive things. I mean, Google came in around, when was it? About mid 1990s, and now it's everywhere. And our whole life has been changed by that and by the internet. And just think what other possibilities there are available to you. I mean, I'm really excited, as you can see, by what's available. And as I say, it's young people that are going to make all the difference. The inventors of Google were about 20 when they invented it. So yeah, who knows what you lot are going to do.
Amazing. Thank you so much, Chris. Indeed, it's all very exciting. Thank you so much for a wonderful broadcast talk. Thank you so much for giving up your time today to speak with us. It was fantastic. So yeah, thank you very much for your Speakers for Schools broadcast.
Yeah. Thank you.
Great. Unfortunately, that's all that we've got time for today. So a huge thank you to everyone for tuning in. A feedback poll should have gone live in the Q&A. So if you have anything to say about today's session, please do let us know. If you don't have time right now, then not to worry. Another feedback form will be shared with you shortly via email. Our speakers love to hear your feedback. So if you have a few minutes, please fill that in. Please be sure to look out for future broadcasts as well on the Speakers for Schools website. Thank you all and have a lovely day.